You can reach me at avadut.kulkarni@progress.com email ID. I have 10 years of experience in building the database driver development, especially on the AD.NET side. I'm owning the AD.NET product line for last 3 years. Currently, the AD.NET product line supports major RDBMS vendors like Oracle, DB2, Sybase, ASE, and Microsoft SQL Server. And we also have entity framework support for all the databases except SQL Server, and we support the latest entity framework 6.0 with both Oracle and DB2 for I. So going forward, our agenda of today's session will be what will be the components of performance, how exactly the component is comprised of, what all different components that can affect performance in an application. Second point will be what should be our performance strategy, and then we will dive into the AD.NET data provider to see how we can get the best out of your AD.NET data provider, what should be its architecture, what connection time improvements we can do, what query execution time improvements we can do, how we can optimize our result fetching in the and some general coding guidelines in using the AD.NET data provider. In this session, I will not be able to cover much of the entity framework because as such this is a very vast topic, and even 1 hour wasn't sufficient to cover the AD.NET data provider as such. So if you are interested in getting some guidelines on entity framework data provider as well, please update us and we will try to schedule something on that as well. In this discussion, we will be mostly talking about the RDBMS connectivities and not the like new data sources on big SQL or big data or NoSQL databases. So going forward is component of performance. So these are the major different components that can impact your application performance. Database, of course, we are connecting to database where our data is stored. So how it is stored, what the resource levels present on the database server, all definitely impact how our application will be performing. So database tuning, indexing, normalization, all these things are very important in your application performance. Second important piece in that is network. Network is like our roads, right? If there is a traffic on network, obviously our commute will be slower. Then if the roads are narrow, the commute will be slower. Or even if you have to travel the road multiple times to complete one activity as well, then your throughput of that particular activity will be slower. So network is very similar in that way. So having a good bandwidth, lesser traffic, and lesser round trips over the network will definitely improve your application performance. Then of course the data provider, your data provider can have multiple configurations, or it can have a built-in features to reduce the usage of key resources, which can improve your application performance. Then your data access code, which can tell data provider that what exactly you want in your application, so that data provider can do some optimized executions to gain on the performance. And of course client infrastructure. So similar to that resource level on the database server, your clients needs to be have a good resource levels, because there are some operations that happens on the local CPU when data providers gets the data back, or even it's doing the connection. So that resource levels are also important when it comes to performance. So going to the performance strategy, what we usually do is we build an application to a business need. Of course, that's what we should do. But when we build a application for a business need, we usually don't take performance that seriously. And once we start seeing some performance issues here and there, client experiencing a slow loading of a page or particular screen, then we start thinking about performance, and then we start fixing the issue. So we should not do this, do not fix your application for better performance. We should design it to perform better. So how we can design it to perform better? Let's have a look on some design guidelines on how you can best use your data adapter in your application. So first important point is architecture. In architecture, I'm going to cover two things here. First is managed versus unmanaged. As we are writing .NET applications, having a architecture is very important. It gives us a lot of important features like garbage collection, type safety, and code access security, to name few. But apart from that, if we are having a lot of unmanaged calls in our provider or in our application in general, it hampers the performance. The context switching between managed and unmanaged, if we are having it very frequently, it definitely hampers our performance adversely. So choosing the architecture of our application as well as data provider is very important when it comes to performance. Apart from that, we need to see like how well our data provider is able to manage the resources. Like, is it well built to utilize the newest and performance benefiting database capabilities? Is it using the network bandwidth efficiently and reducing the round trips over the network whenever possible? Is it reducing the disk I/O operations, which are performance costly? And how efficiently it is using your CPU and memory on your client side as well as server side. So it can provide some hints to server on using that server can reduce its CPU and memory usage. So we will touch upon the data provider aspect of this in detail. We will divide this discussion into three different sections as I talked in the agenda slide. One is connection time improvements, second query execution time improvements, and third is result fetching. Though we are dividing these into sections, there will be few common factors which will be impacting others. So I will anyway cover those points when we go there. So during connection improvements, first and foremost that comes to my mind is enabling connections for distributed transaction. So most of you might be aware that distributed transactions are transactions which have scoped over multiple connections, so that we can still have atomic operations executed on multiple connections. But for few databases like DB2, even before you start a distributed transactions, when you are creating the connection, you need to tell database that, okay, see, I'm going to create I'm going to use this connection in a distributed transaction. So prepare this connection that way. So creating connection in itself is a very heavy operation, and we will see why it is in few seconds. But having it prepared for distributed transaction is even more possible. So we need to make sure that we are only enabling this distributed transaction enabled feature on the connections which are really going to participate in distributed transactions. Otherwise, a normal connection would be better than, say, enabled or distributed transaction enabled connection. Second most important topic here is connection pooling. So as I said, creating connection is a very performance heavy operation. So instead of multiple times creating the connection and closing it, can we reuse the existing connections to improve the performance? So connection pooling is that feature. So while discussing connection pooling, we will touch upon what are its benefits, what are the different pooling strategies that we can employ, and situations where we should avoid the connection pooling. So in general, the suggestion is use connection pooling, but there will be few situations where we need to avoid it. Then bigger protocol packet size. Packet size is usually the buffer sizes which are used over the for the network communication, for the data transfer over network. So using bigger protocol packets usually means lesser round trips. So we will touch upon that. avoid distributed transactions in general. So we will discuss distributed transactions are slower than your normal transactions. So general guideline is avoid them. So we will see why we need them and is there possibility that we can avoid them. And of course security. Security is very hot topic nowadays, and usually having more secure communication usually means slower communication. So we will see if we can have some good balance between security as well as performance when it comes to that point. So let's see how what connection pooling means and how it works. So let's see an animation. There is an application server, and when it started, it gets populated with the different connections already connecting to database. So these are connections already connected to database and ready for use for your application. So your application comes and requests for one connection. So that connection is available in the pool. So that connection is returned to the application. And now application is connected to your database, doing all its operation necessary to execute the business logic. Once the work is done, your application is now connected to database. Now once the work is done, your application closes the connection. Once the connection is closed, it does not actually disturb the physical your connection and database, but just returns the connection to your connection pool. That way, you reduce the recurrent time you spent on creating the physical connections and disconnecting multiple times. So why the connection creation is so much performance heavy operation? Because first it needs to create the socket. After the socket is created, there will be a lot of negotiation going on between server and client to determine what should be the network buffer sizes or packet sizes that they should use for communication. And if it's a secure channel or encrypted channel, they need to validate the keys and certificates and decide which encryption keys they will use for the encryptions and all that. So there are a lot of stuff going on and multiple round trips happening while creating the connection. So using connection pool usually helps you to improve your performance time. But one thing we observe here is when the application started, we actually populated all our pool at the single time. So that impacts your application startup, because there will be a lot of connections created when your application server started. So another strategy for that, another optimization there you can do is just create a connection when it's required. So it will check the connection pool. If the connection is available matching your request, you will get it. If the connection pool is do not have a connection matching your request, the new connection will be created. Your application will use it, and when it closes it, it will return to the connection pool so that it will be available for the next request. So creating the connections as and when you require and closing as soon as your work is done is the best strategy when it comes to connection pooling. There are a few database drivers who even support more complex strategies like first in, first out or last in, first out to make sure that based on which connection means or gives better usability to the application, those strategies can be employed and used. Not all data providers use these strategies or have a configuration option to applications to choose those strategies, but yeah, few of them does. So when to avoid connection pooling? If your application restarts very frequently, then connection pooling won't help much, because whenever you populate your pool, once the pool is populated and your application stops, you actually lose most of the connections that are already populated. Actually, I'm seeing few questions coming in, but I will take the questions at the end of some time allocated to that. So keep posting your questions into the questions pane, and I will try to answer them at the end of the webinar. So second situation where we can avoid connection pooling is single user applications. So as these are single user applications which are connecting to database once in a while. So the benefit of connection pooling is very less in this case. So having the pool and like locking those many resources for the connection pool usually reduces the performance. Then it can help to improve the performance in this case. And obviously the single user batch jobs, which are like your syncing jobs or cleanup jobs, which are anyway you try to run them during the off hours and such. So in those cases, the pooling is not much beneficial to your application. So coming to the as we discussed, protocol packet size are actually the sizes that client and server uses to. It's a buffer size which client and client and server uses to transfer the data over wire or network. So these are sizes you configure both on server as well as your data provider side. Your data provider and server uses these values to initialize the buffers, and then when you actually send the data over the network during connection as well as during query, you can use this buffers to communicate the data. So the bigger the buffer, your more data will be transferred in the single round trip. So in general, total data transfer will have lesser round trips if you have bigger protocol size, protocol packet sizes. So general guidelines is use your bigger protocol sizes. And as you configure the server to use max packet size limit, try to make sure your client matches that value so that the communication size will be maximum that can be used on that connection. And now it comes to distributed transactions. As I already explained, that distributed transactions are usually used when you have multiple participating in the single transaction. So suppose there is a company which has different database for their payroll and accounting. Okay. Now when we do salary for an employee, we need to update both these databases, payroll as well as accounting. But then because they are on different databases, we have different connections connecting to them, and hence we need to use distributed transactions. So yeah, there is definitely a business case there where you need to use the distributed transaction. So you have to be very cautious when it comes to distributed transactions during designing your architecture of application to see that the necessity of using distributed transaction will be very minimal, and try to avoid them as much as possible. So distributed transaction can go over a single database, like two connections connecting to a same data source like Oracle, or it can have a cross connectivity like one on SQL Server and other on Oracle or something. So general guideline is try to avoid distributed transaction unless it's mandatory by your business case. So topic is security. So there are two levels of security which we usually use in our application. One is network authentication. So we can have Kerberos or NTLM to use the for the authentication methods, and then data encryption over networks like SSL or some database specific encryption supported by databases. So let's see what we can do during the authentication. So by taking a case of Kerberos, usually the bottleneck in Kerberos authentication is the ticketing system. Your Kerberos server needs to create a ticket and give it to client so that it can send that ticket to the server and get authenticated properly. So your Kerberos server becomes bottleneck of the authentication performance. So there are some general guidelines to how you can make your Kerberos server more efficient, like placing your Kerberos server on a dedicated machine, having good bandwidth to that server, reducing network services running on that machine. Using that, you can reduce this bottleneck and have better performance with encrypted authentications. When it comes to data encryption, data encryption is usually a layer over your TCP/IP. That may be a proprietary encryption by database vendor or SSL. And when it comes to data encryption, there are two performance intensive steps there. One is initial handshake. It takes a lot of time during the initial handshake because there are multiple round trips involved to certificate and key validation, cipher negotiation, and usual connection creation stuff. So initial handshake is one of the performance heavy step. Apart from that, for every data transfer, you have to go through encryption and decryption cycle. So using encryptions for security is usually performance heavy. And if you use longer cipher keys, that means cipher keys with higher strength, those usually provide you better security, but obviously it takes more time in the encryption and decryption, so that reduces performance. So we should be wise in choosing the level of security or the strength of ciphers that we are choosing for our encryption. Going for the best security is always good, but you have to always keep in mind that it will impact performance adversely. So there is one general performance tip we can have here is we can divide the data we access into two broad categories. One is sensitive data, which you want to encrypt in any case, and then non-sensitive data where you don't care much about the security in your application. And then you can use your encrypted connections to retrieve or insert or do operations on your sensitive data, and unencrypted connections for your non-sensitive data. Though not all of the databases support this functionality, but few of them definitely support, where you can just connect using SSL, your logon credentials and all that will be transferred in the encrypted format, but your data transfer can happen in non-encrypted format. So this was what we can do during the connection. So how we can improve our query execution performance. So let's see what different things we can have. Okay, so here we are saying that use transactions or auto commit. So this is exactly opposite that our suggestions was to avoid distributed transactions, but you should make good use of local transactions to improve performance. And we will see in a while why that is so. Then use prepared queries. Prepared queries is a kind of cached queries which your application execute multiple times. If you know your particular query is going to be executed multiple times, you can cache it and use a better use of them. So we will touch upon that. Then using statement caching or pooling, it's similar to the connection pooling. Instead of creating the statement object multiple times and closing them, it usually more network round trips as well as resource wastage. So we can use of statement caching and pooling to improve the performance. Use parameterized batching. So when you have to insert like 100 rows or million rows into a database, the single query but change of the values, executing them separately queries. Suppose I'm doing an insert on the database, I can use question marks or parameter names as a placeholder for my values, and then I can execute the same query with multiple values to get use of prepared queries or statement caching in my application. So this way you can have parameterized queries to make better use of your statement caching instead of the static queries where you are inserting using literals. Then another guideline is your statement pool max size should not exceed your server limits of maximum number of active statements, because if that exceeds, most of the active statement will be pooled and present in your max pool, and when you try to execute a new statement, your application will fail to execute that because the server's limit is exceeded. And to get a better use of application statement pooling is make sure that your statement pool size is equal or more than the different statements that you are planning to execute multiple times. So as we were discussing earlier, in the dynamic queries, we can have parameter markers or question marks as a placeholders, and then we can have multiple executions with different values to get use of prepared queries, which is definitely faster than static execution using literals. But you can actually make use of a feature called array binding, which your data provider and server both needs to have. But using array binding, what you can do is you can send multiple sets of your values in a single round trip. So that suppose I want to insert 100 rows in a single go, I can create array of 100 values and attach it as a single parameter to my application. And then the single execute will insert all those 100 records into my database. So this gives you even more better performance compared to the prepared queries or statement caching. So this will reduce your network round trips, and you can utilize this feature also with your data adapter. So data adapter has update batch size field. If your data provider do not support array binding, then usually this update batch size value is set to 1, which is its default value. But if your application want to make use of this array binding in your data adapter, you can set the update batch size value to the number of records you want to insert or update in single go, so that your data adapter.fill or data adapter.update can make use of array binding internally and provide you a better performance. So again, as I said, not all data providers and databases support this feature. So you have to go through the documentation, sure that the database that you are using and the data provider you are using has this feature before you can make use of it. So okay, your array binding is providing a even better performance than your normal prepared query inserts. But then there is another feature which can give you even better performance than your array binding, and that is bulk load. So bulk load or bulk copy are like special protocols or special features provided by your database server, which can give you even faster performance than array binding. To check if your data provider supports this functionality, you can just look for XXX bulk copy class in your provider. Many data providers support this functionality, so you may be able to find that and make use of it to insert your huge volume of data into databases. In bulk load, rows are sent as a continuous stream, so it does not make any extra network round trips. And because there are less round trips, the insert goes more faster. And also database also optimize the way they are inserting the records when it comes to bulk copy. So it makes it even faster. But there is a drawback here. When you are using bulk load, sometimes the databases ignore the referential integrity. So you may have some data consistency problems if you are using bulk load to insert your bulk data into databases. So that was about how you can optimize your query executions. Now coming to result fetching, you can employ some tricks there as well. So one is delaying retrieving long data. If your tables have a long data columns, then it's not recommended to use those columns in your select list. try to have a data which do not contain long columns as your basic business need, and only if the customer is interested in particular long data, only then fetch that long data column is a general better performance strategy. And obviously, because the long data are supposed to have huge data, there will be multiple network round trips to fetch that data, is single most reason of having slower performance when it comes to fetching long data. So general guidelines is, if your table has a long data column, do not use select star because it will be always slower in the performance. And even do not explicitly use long data in the select calls as well if your application don't need it at that moment. And another way is limiting the amount of data you can retrieve. So sometimes your table might have millions of records, but you just need top 10 or top 15 records to be displayed at a particular moment. So you can limit the number of rows fetched from the server using your data provider's properties like max rows or row set size. If you know that, okay, the first 15 rows is just one fetch of the data, and you are supposed to fetch the next rows, next 15 rows and next 15 rows like that multiple times, you can use offset and limit clauses to make sure that you are fetching a particular page at a time instead of doing complete select on the data. Because we are limiting the number of rows fetched from the server, it will reduce the number of round trips required to fetch that data, giving you a better performance. And again, when you are trying to fetch long data columns or huge data, like suppose I have a table which store a log entry, which is like 10 MB in the size. When I'm fetching that particular column based on the business requirement, I can just fetch a snapshot or a few initial bytes of that log entry, like 1 MB out of 10 MB. I will fetch and display it to the user. So again, it all depends on your business use case, but that definitely makes sense if you can do that to just pre-fetch some part of your long data and show it to customer and fetch the entire entry only if it's required. You can think of when we are browsing Facebook on our mobiles, right? We just see a snap of the comment, and then we see a read more kind of button. When we click on that, we actually see the entire content of that particular entry. So you can think of this as a similar feature you can employ. There are two ways to implement this. Some of the databases support prefetch LOB feature, like Oracle supports it, so you can make use of that. And if your database do not support it, you can probably think of writing your SQL queries intelligently to use cast operations to lower character sizes or binary sizes to fetch just initial few bytes of your data. Another important note here is it's actually kind of coding guideline that when you are using data reader methods to get your particular column values, try to use get specific type like get end, get float methods instead of using get value, because get value returns a reference type instead of the value type, so it needs to box. It needs boxing and unboxing when you are using get value, and store. You want to store that in a simple value type. So, to avoid the boxing, you can always use get specific type like get int 32. And actually, if you try to measure a single call, it's not that much performance impact. But considering the volume of data go through the database drivers in applications, it can quickly be very measurable and performance impacting thing if you have multiple gates impacted by this. And choosing right data types. So these are a few data types, and they are actually ranked in the order of the process needed by your data provider after fetching those columns. Like if I fetch a binary column from database, it actually transfers into raw bytes. So your data provider do not need to process much on that. So it's usually faster to fetch binary data. Then the data types like integer, small int, and float, they usually have a fixed formats. So the processing needed on the raw bytes is very minimal. So they come second in the line. Then comes decimal types. They are usually stored in the proprietary formats, and sometimes so driver needs to decode them and use CPU to decode them. So decimals are third in the line. Then it comes to the date and timestamp data types. Again, they are stored in some proprietary formats, and your driver needs CPU cycles to decode them. These are actually very compared to decimal, but because your timestamp fields have multi-part string or multi-part structure, they are usually little heavier than your decimals. And character is considered to be the heaviest when it comes to processing, because you need to change the code page and have a code page translation on all the character data that you are fetching from server. Actually, code page translations are not that CPU intensive operations, but it is always proportional to the size of data that you are processing. So if you have a large number of character data coming from your server to client, this will definitely impact your performance. These are how you can make a better use of your data providers by using some configurations or tricks with the data providers. These are some general coding guidelines. So while executing statements, we have three different APIs provided by edu.net. The first is execute non-query. This returns number of rows affected but does not return any actual rows. This is specialized API to execute your DML operations like insert, update, delete, where there will be rows affected but no actual data written by the execution. Then you have execute read. The objective of this API is to return the complete result set. So the use case of this API is executing your select queries. And then you have execute scalars, which just return the first column, first row of your result set. So this is usually used when you have aggregate functions like count star or something, which are expected to return a single value from your execution. So this API is usually optimized for that kind of usage. So though all these three APIs can be used for any query, like I can use a select query inside execute non-query or just DML operation inside execute reader. Using them for their specialized purpose helps improving your performance because they are optimized in that way. Another general coding guidelines is, like I have already touched upon, using like having your architecture as 100% managed. So 100% managed providers usually provide you a better performance compared to the other providers which need some unmanaged calls or integration with unmanaged database clients. So that is one of the good decision points you can make in improving the performance of your application. And how to select the .NET objects in your application. Like command builder are good when you are programming, and it gives like a lot of development speed because you don't have to write all the insert, update, delete statements for your data adapter update functionality. But then when it comes to runtime, command builders are very slow because every time you update command will regenerate those in. So that's one is usage of usually because very efficient fetch your data is have result set where that data, then data set makes more sense for your application. So based on your business need, you should be able to choose right between data reader or data adapter, I mean. So most of this content from in this webinar are coming from a single book, the Data Access Handbook, written by veterans in our Progress Data Direct Division, John Goodson and Rob Stewart. If you get access to this book, you will find lot of detailed analysis of each of the points that I have covered, and even few more which I have chose to skip in this webinar. So that's all from my side. So thank you for listening patiently, and I will now check if you have any questions.